Hi, everybody, and welcome to the Smart Human Podcast. On today's episode, I have the pleasure of speaking with Dr. Pete Myers, who is founder and chief scientist of Environmental Health Sciences. He is also one of the 3 authors of Our Stolen Future that was written in 1996 and is really considered one of the forefathers of the endocrine disruption chemical movement. Today we talk about endocrine disruptors and the history behind them, regulatory issues, and the future of green chemistry. So stay tuned. Hello, everybody, and welcome to the Smart Human Podcast. Today, I have the pleasure of speaking with Dr. Pete Myers, who is founder and chief scientist of Environmental Health Sciences, a not-for-profit organization that promotes public understanding of advances in scientific research on environmental and human health, especially on how chemical exposure, even at low doses, can cause serious adverse effects. He's also founder and board member of Sudoc.com, a chemical company that makes catalysts that clean up bad stuff and also replace dangerous chemicals used as disinfectants and cleaners. We have a lot to talk about. Thank you so much, Dr. Myers, Pete, for joining me today.
It's a pleasure to be here. Thank you.
So you have a pretty colorful, interesting background. You were one of the first people that I met in the endocrine disruption world of scientists back several years back. So I wanted to get started by just kind of giving, if you wouldn't mind, a background on the big brunt of what you've been studying for the better half of, I would say, 30, 40 years now.
Yeah, I started being concerned about endocrine disruption before it was called endocrine disruption. When I met a wonderful scientist named Theo Colborn, who got a PhD at the age of 57, and then she changed the world. It's a wonderful story. I won't have time to go into it all, but if you ask me, I'll tell you stories about it. In any event, Theo had noticed in the late 1980s that studies she was doing of wildlife in the Great Lakes, where she expected to see cancer, a lot of it, because of how contaminated the Great Lakes were. Instead, she saw things indicating that something was going on with hormone signaling. Curved beaks in fish, curved beaks in birds, birth defects in fish, and a wider range of other things that were not cancer, but were causing big problems. And she began to put this together and realized this is a huge issue. I was working on something completely different at the time. And she heard me lecturing about this in Washington, D.C. We had never met. But at the end of my lecture, she comes running up to me, grabs me by the shoulders and shakes me and says, "Pete, we have to work together." That's how I met Theo Colborn. I tried to create a job for her at the place where I was working at the time, and it didn't work out. But I was shortly thereafter offered a job to run the Alton Jones Foundation. And as a part of a condition of my taking the job, I said, I want to have 2 scientists come with me because I want to keep my hand in science and not just in grant administration and planning. And the board agreed. And so one of them I hired was Theo. She became a senior fellow. And we really began to dig into what were the broader implications of what she had observed in the Great Lakes. We pulled together a meeting in Wingspread, at the Wingspread Conference in Racine, Wisconsin in 1991. And it was there that the term endocrine disruption came to be. I actually suggested it. But that conference led to a Wingspread statement, which is pretty much the foundational document of endocrine disruption as a field. At the time, we were in the medical wilderness. It was a wonderful meeting. People were there. Fred von Sahl was there and was one of the key players. And what Theo had done was she was a voracious reader of diverse literature, scientific literature. And she had identified a range of people who didn't know each other, but all of whose work directly bore upon the questions she was trying to ask. And she said, come on, let's get together and find out what the common features are. And see what we can determine. And that's what led that her ability to pull together different pieces from disparate places. We had Fred, a reproductive biologist. We had Howard Byrne, a famous endocrinologist. We had people from immunology. We had a psychoanalyst, all sorts of different specialties. Only about 20 people. But she had seen the common factors that united their work, and we drew it out at the meeting, and we wound up with a consensus statement that said, we are certain that something's going on. There are lots of questions left to answer, even to ask, but we know something's happening, and so let's get to it. And that was where the field really got its boost.
And so in the field of basically endocrine, for those who are picking up this lecture and this interview and don't really know the basis of endocrine disruption, give a brief understanding of what endocrine disrupting chemicals are and endocrine disruption is in general, and how that affected wildlife and now connects to human health.
Yeah, well, let me answer what is endocrine disruption first, and then identify a few endocrine disrupting chemicals. So we have this system in us, this chemical signaling system called the endocrine system. It's hormones. And hormones are made in one part of our body and then travel through the bloodstream to another part of our body, where there are receptors. There are receptors that have evolved specifically to respond to a specific hormone. So the hormone arrives, it binds with receptor, or there are several different pathways that can take place. But when it binds with the receptor, often what happens is certain genes are turned on or off. And turning genes on and off is one of the most crucial steps in life. It's what allows a fetus to develop to an adult. If you get the wrong genes turning on at the wrong time, or a gene doesn't turn on when it should, something's going to go wrong in the development of that person. So that's endocrine disruption. When chemicals interfere with that process. Some chemicals have the similar shapes to hormones, so they can bind with receptors that hormones normally would bind with, or they can block those receptors. And that process of binding when they shouldn't, or blocking when they shouldn't, and preventing the expression of genes that are crucial for development, that's endocrine disruption. There are other ways to do it. You can change the amount of the hormone that's produced, or you can change the number of receptors that are present to receive the signal. But bottom line, it's interfering with that hormone signaling that is vital, absolutely essential in driving proper development of the fetus from fertilization all the way through to my age and even older than me. So that's what endocrine disruption is. Yeah.
Yeah. And I always liked the coined phrase, disruption, because it really kind of keeps the window open for new science that develops, showing different mechanisms of how these chemicals disrupt not just the endocrine system. Of course, we now know the metabolic system in terms of diabetes and obesity, also the immune system. So this concept of disruption and not closing it, keeping in a box when we know there's even more science to come out of this, I think has always been an interesting title.
Thank you. I am responsible for that because one of the other things I was working on at the foundation was climate disruption. Mm-hmm. And actually, I had written an article about what is the future of climate disruption, especially for biological diversity. And I called it climate disruption at the time because it wasn't just heating. It wasn't just warming. It was messing up with the whole climate system in ways, some of which we understood then and some of which we didn't yet. And so I just written this article about climate disruption when the Wingspread conference hit, and I'm thinking about all that. And then I listened to all these people at the meeting, and I see, oh my God, it's not one system. It's not just the estrogen system or the androgen system. It's not just blocking a hormone. It's disrupting the system. And you are exactly right. It left room open for us to learn new stuff, but put it under one title.
Yeah, disruption. We know things are screwed up. The mechanisms are the nuances within, but I think that was kind of not that you predicted all of the enormous international bodies of research, the World Health Organization, all of these huge bodies that now have embraced the concept that endocrine disruption worldwide is a major problem. And I think that wasn't predicted.
Yeah, the World Health Organization, along with the United Nations Environment Program, published a paper in 2012 saying endocrine disruption is a global public health threat. Period.
That needs to be addressed, quote unquote.
Yeah. And so, actually, early on, after we wrote Our Stolen Future and published it in 1996, and during the process of learning all that about all the potential for disruption, because when you really begin to dig into it, you realize, wait a second, any hormone signaling system is vulnerable to disruption, and we have produced tens of thousands of novel synthetic chemicals, very few of which have been tested for potential effects like this. And so I began asking, well, what are the hormonally regulated processes that we don't know about yet that are being disrupted? And I would go to scientific meetings in 96, 97, 98 and say, okay, so this is what we know now. Are any of you studying disruptions of the metabolic system? Are any of you studying how endocrine disruption might contribute to the epidemic of obesity? And no one had an answer for that. Neither did I. I just knew we had to ask it. And I even made a grant to Fred von Sahl because of early work he had showing that BPA in certain circumstances caused obesity. The Jones Foundation gave him a grant to study that farther. I even hired a research assistant who was working for me at the Jones Foundation to review the literature on toxicity to ask, are there any indications within that literature suggesting that sometimes toxic compounds cause obesity? And we found them, but I had a full-time job. My research assistant left. I never published it. And then about 2 years later, a famous paper came out of England saying, there are plenty of indications in the toxicological literature showing that sometimes toxic compounds cause obesity. And then our mutual friend Bruce Blumberg stepped in and coined the term obesogens, and that field has taken off. It's amazing the full-scale implications of obesogens, endocrine disrupting compounds that cause obesity, for health.
Yeah, and what's so interesting is one thing that I think, having been doing this for a while, both you and I think we forget, or at least I sort of take for granted, this concept that is so hard for people to grasp, which you talk about with, your book, Our Stolen Future, which I want you to talk about, that you wrote along with Dr. Theo Colborn. But what really is the critical piece that I, as a lay doctor, believe it or not, as I got into this very late in my career, wondering why I have so many sick patients that have endocrine issues and immune system disorders, and then stumbled into it, through my dog getting sick, and there's a whole story behind that.
I read your story. It's beautifully written.
Thank you. And it was out of my heart and out of sadness that brought me into this field. But one of the things I could not wrap my head around, just as an average human being living in this planet, was how can chemicals that first of all, how are they on the market that I'm using every day? And who's protecting us was one of the key questions. I said, why didn't I learn this stuff in medical school if it was such a big deal, if it was real? And then really more important than all of this is, how can low-level exposures affect health? In other words, this whole, clash with conventional toxicology where dose makes the poison was a really hard something to grasp myself. And you guys went head to head with some of the biggest thinkers in toxicology, and this hundreds of years of this belief that if it's a little bit of exposure, doesn't do much. So tell me how you started to formulate this argument for the book and for all the work you did thereafter. Well,
there are multiple questions you've just wrapped into one, and so I'll start. But don't hesitate to bring me back to what you wanted to have answered. I'm going to begin with a story about Fred von Sahl and me, where we were at a retreat organized by Theo and Dianne Dumanoski, the third author of Our Stolen Future, to bring in knowledge from people like Fred. And Lou Gillette was at the meeting also. And Fred took me aside at one point and showed me this new graph he had of bisphenol A effects on prostate size. Not yet published. This is 1993 or 94. And it was an inverted U. So as the dose went up, this prostate size went up, but as the dose went up farther, the prostate size went down. And then it went to 0. And I'm looking at that, Fred, and I said, Fred, that can't be true. If it is, all of regulatory toxicology is wrong. Because in regulatory toxicology, the dose has to keep going up for it to be real. In fact, in 2019, the FDA published a decision in the Federal Register where government agencies publish official positions. And that statement in the Federal Register said the following: for a statistically significant adverse effect to be toxicologically relevant, the effect has to increase with the dose, period. So they were ruling out by fiat any it's called when it goes like that, it's called nonmonotonicity. I can go into the details if you want. But the FDA is still fighting this in 2019, registering in the Federal Register that nonmonotonicity, that sort of dose response curve, is not toxicologically relevant. So that's where my knowledge of this began. Fred responded to me when I said that can't be real. Was wait a second, that's basic endocrinology. Now, I was not trained as an endocrinologist. I've learned a lot of endocrinology over the last 30 years, mostly by being willing to ask stupid questions of people like Fred von Sahl, who tolerated my stupid questions. But Fred and I began to work then on how do we think about bringing the regulatory agencies along on this issue, because it changes everything. Let me give you one example. In the late 2000s, the NIEHS and the FDA began a research project called Clarity BPA. Clarity is an acronym for some long set of words, but BPA is bisphenol A. And what they were addressing was the fact that the agency, both EPA and the FDA, and all agencies around the world who do the same thing, find out what's safe and what's not, anyone who had weighed in on the toxicity of BPA had said it's not toxic, the agencies. At the same time, there were thousands, literally thousands of academic studies using procedures from the National Institutes of Health, using modern medical science to determine what's safe and what's not. Thousands of them that said, yeah, low doses of BPA are a problem because it's an endocrine disruptor at those doses. And so the FDA said no. NIH said, well, why are you ignoring all this academic studies that we fund, that we vet, that use science much more advanced, much more modern than what the FDA uses? Why are you rejecting our work when you should be using it? So they came to an agreement. The FDA and the NIEHS, National Institute of Environmental Health Sciences, would collaborate in a big study. It cost over $30 million. It's a big study in which you would have the FDA do its classic analyses. They would raise the rats and then do their classic analyses of what's toxic and what's not about BPA. But they would also after dosing the rats, they would send some of them to academics. The academics would publish findings saying BPA is a problem at low doses, saying that there are non-monotonic dose response curves in studies of BPA. So they wanted to see why was there a failure for the two sets of data, FDA's and the academic work, to be congruent, to be reporting the same thing. It took a long time for that study to be completed. And when I first heard about it and I heard the details, I told Fred, who was one of the scientists who was involved in it, and several others, I said, they're setting you up for failure. They are designing the experiment in a way in which you are not going to find positive results. And I could go into the details of that. I still believe that that's the case. In fact, the head of the FDA part of the FDA that regulates chemicals in food, the Center for Food Safety and Applied Nutrition at the FDA, in their first meeting with the scientists said, I don't care what you find, we're going to ignore it. Okay, I don't know if Fred has ever told you about that.
Well, no, but look, it doesn't surprise me. I mean, this is a David and a Goliath type of area as far as I've seen. It's gained so much more traction and so much more, interest by popular media. As we know, it's taken 20 years, 30 years. But 30. The idea that, but it doesn't surprise me. I guess the question behind that is, well, what interest did they have in not supporting the scientists, from the NIEHS work? Where was that drive?
Non-monotonicity. Mm-hmm. The fact that the slope of the curve, up or down, changes as you move along the dose. That's the mathematical definition of non-monotonicity. Okay, mm-hmm.
So it looks like a J curve, a U or a J for the audience. Instead of linear U, like this, it's upside down like a U or a J.
Yeah, or a U. Okay,
or U.
So it's an existential threat to the chemical industry as it is currently practiced. That's why. And there's something called the revolving door, where FDA employees spend time at the FDA, and then they go work for companies that protect chemicals for industry. I'm sorry, it's that simple. And I can give you an example of where I had to confronted that directly. Let me tell that story and then return to your questions, okay? Fred and I and 10 other scientists and people studying endocrine disruption came together. I brought them together in about 2009 to write a large review of non-monotonic dose responses and low-dose effects of endocrine disrupting chemicals. It's got 870 odd references in it. Laura Vandenberg, I recruited Laura to be the lead author. I was the senior author. I chaired over 100 conference calls over 3 years to get it done. And when we finished, we had made a just unassailable case that non-monotonicity was common. It was what you expected in endocrine disrupting compounds, and it was very common. And so we decided we owed it to the FDA to give them the heads up. We're going to come out with this paper. So we had a meeting with the senior people from the FDA's Center for Food Safety and Applied Nutrition and presented the results. And then we broke into little groups. And I was there meeting with one of their top scientists on this issue across the table. And she said, we don't see things like that. We don't see low-dose effects. And I said, of course you don't. You don't test at the levels that are relevant for non-monotonicity. And she thought, oh, you're right. Then literally 15 minutes later, I heard her tell one of my colleagues on the paper, Tom Zeller, the same thing. We don't see those things. A year later, she had a job for a product defense firm, paying her 10 times what she had earned at the FDA annually, plus a big bonus. That's the revolving door. That's one reason, not the only reason, but it's one reason why it's really hard to get the regulatory agencies like the FDA and the EPA to change. It's sort of like, how being on the congressional staff at the age of 25 is really cool. It's wonderful on the Hill. There's a lot of stuff going on, very exciting, but you don't earn a lot. The payoff is when you leave the congressional staff and go to work for a lobbying firm where you earn a lot of money. So it's sort of like you got to pay your dues before you get to the big money. And I think that's part of the factors that's motivating the FDA and the EPA to not do their things. And we've read about this recently. There's a reporter at the Intercept, which is a online investigative reporting group, a woman named Sharon Lerner. And over the last 2 months, she's published 4 stories showing absolute corruption in the EPA, where the managers of the scientists are literally editing and changing their conclusions from, whoops, we better worry about this, to not a problem. They even had a category of chemicals they formerly called hair on fire. Okay, that was the language they used in the agency. This is a hair on fire chemical because there's a company that's really pushing to get it approved rapidly. And they even changed some of the ways the software works, so they push a button and would change the ease with which the chemical worked through the EPA's approval system. I'm sorry, you want to think that these agencies that are just there in place by law to protect our safety, the way that it's evolved over time is they've become corrupt. It's that simple.
Yeah, and
I guess, there are good people. Well, let me.
Yeah.
There are really good people in the agency still, but overall, it's a problem.
And how does it compare to Europe and Canada and some of the other places where, chemicals have been more rigorously overseen, evaluated, removed from the market?
Well, take Europe as an example. I do a lot of work in Europe. I'm on the board of a Swiss organization that works on chemicals. I have chaired for the last 10 years a call every other week asking, what do we have to do to get endocrinology and endocrine disruption science inserted into law in the European Union? Because the European Union has been doing a lot of reviewing of how they regulate chemicals. They've realized something's wrong here. Let's try and get it right. And so we've been providing input about endocrine science there. The agencies are also have problems of conflicts of interest. We've had to confront that directly. But what's happened is the public has become hugely animated about chemical safety and has pushed the politicians. And the European politics is organized differently with the European Parliament and the European Council and the European Commission. But we've managed, on October 14th, just under a year ago, 2020, Frans Timmermans, the executive vice president of the European Commission, issued the first public announcement of the European chemical strategy for sustainability. And over 10 years of those conference calls, we managed to get them to take endocrine disruption science seriously. And he acknowledged the Endocrine Society explicitly and endocrine principles explicitly in how they are proposing to manage chemicals. It's always the case you can get them to make a strategic announcement, and that's good. You need that. But then now we're in the battle of how it's actually going to be implemented. So the battle is continuing.
So it's not just a U.S. issue, essentially.
No, the chemical industry is really powerful. And, we need chemicals. We really do. We just need much more attention to be paid to their safety using modern science instead of using principles that, in this case, the Nonmonotonicity, the governing principle for regulatory agencies, dates out of the 16th century. That's not an exaggeration. That's where that phrase, that does make the poison, comes from.
Yeah.
Paracelsus, exactly.
Absolutely. And so when I look at, our stolen future in preparation for this conversation, and I read this 10 years ago, actually, when I was first getting involved in this area and trying to learn more about it. What has changed since this time? I mean, what can you say? All of this is legitimately true and it's still valid today. I mean, if you read the material, it's legitimate, it's valid, it gives the story behind endocrine disruption. But in your opinion, where do we stand now? How have chemicals, in terms of their number, their ubiquity, how has that changed over this time period?
First of all, I want to make an apology. My camera is right up there, but you're down here, so I'm always looking off to the side. I'm really trying to look at you, okay?
No worries.
So just about everything we wrote about in Our Stolen Future the certainty of it has increased since we published it 25 years ago. It's very gratifying because we had a lot of maybes in that book. In fact, the chemical industry counted the number of maybes we used and used that in arguments against me in debates. You used 221 maybes. This couldn't be science. Well, we acknowledged there was uncertainty. What we were trying to do with the book was to stimulate public interest and funding of the science so that we could answer the questions we had asked in the book. Some of those questions have been asked with certainty, but I think even more importantly, issues like obesogens, like immune system disruptors, which we didn't speculate about in the book because there was almost no science. Maybe a little bit about immune system, but nothing about obesogens. Those have come to the fore. The range of diseases, of chronic diseases that are non-communicable, obesity, diabetes, ADHD, autism, the range of diseases that are now known to be affected by endocrine disrupting compounds, that's expanded dramatically. Heart disease has emerged as a major target of endocrine disrupting compounds. And I should say, that none of those diseases are unifactorial. They're all caused by multiple things converging on the same genetic pathways, leading to changes in the expression of genes that then cause the problems. My argument would then be, okay, so we can reduce exposures if we make a commitment. It's much harder to change lifestyles, and it's impossible right now to change our genes. We can change gene expression, we can't change our genes. Okay, we can't change the DNA sequence. But so what that means is, as I gradually began to understand the long-term implications of this, it became hopeful. Because, you think about when you first started to learn about the Human Genome Project. You'd read something in a newspaper or in a technical journal, and they'd link this disease to this gene and that disease to that gene. And the response of most people was, oh my God, did I get the gene? Well, my response, and that's very fatalistic. You either got it or you don't. My response was, wait a second, what's altering that gene's expression? What's turning it on or turning it off when it shouldn't be? What chemical is involved in the causation of that disease by affecting gene expression? If we can identify the chemical, then we can have a plan to reduce exposures. That's possible. That's good news. And so that's what animates me. And I've even, you mentioned Sudoc, a company at the beginning. I've even now gotten, I'm on the board. I helped found a company that's trying to reduce the amount of endocrine disrupting compounds that are in the environment and that are in us. It's a big change because with our Stolen Future, during that phase of the work, I was always saying, no, Mr. Chemical Company, no, Mr. Chemist, don't do that. And now I am consciously setting out to help chemists make money by designing safer materials. And the wonderful thing about one of the big advances in the science over the last 25 years is we now know enough, not in all cases, but in a lot of cases, to look at the molecule, say that's why that's a problem. Let's design another molecule that achieves the same material characteristics. It does what we need them to do, but it doesn't interact with the estrogen receptor or the androgen receptor. So I'd love to now tell people I'm trying to help chemists make money because we can.
And this is green chemistry, technically, right? I mean, would you call this green chemistry? Yeah.
Yeah, or sustainable chemistry. Yeah, definitely. And my closest colleague in this is Dr. Terry Collins, who is Teresa Hines Professor of Green Chemistry at Carnegie Mellon. You know Terry. You know what a wonderful guy he is. He's a genius. I describe Terry as the Richard Feynman of chemistry. Now, Feynman was a physicist at Caltech who, more than any other living physicist, was able to see beyond the immediacy of a given physics problem and intuit the answer. Terry does the same thing in chemistry. And it's been a privilege for me to work with him for 15 years. And he and I actually wrote, along with 20-odd other people, a big paper. We published it in 2012. I was the senior author. We wrote this specifically to provide chemists with an intellectual framework that would allow them to design chemicals that are not endocrine disrupting compounds. And that's one of the things I'm proud of about Sudoc. We are implementing those that intellectual framework, because we're not.
It's interesting.
The problem is.
Yeah.
Oh, go ahead.
No, I was just going to say the fact that you're loud and proud about, funding, making it lucrative for people to do good things, as opposed to sort of, a lot of people are sort of veiled and sort of kept restrained by academic an environment where they're not really allowed to venture forth and make money off of doing more innovative work that has to do with maybe green chemistry or and I think it's like David and Goliath, because the money that's involved with these plastic companies, these petrochemical companies that make little plastic beads that turn into everything, or chemicals that go into makeup or nonstick pans, it's a Goliath. And so what you're doing is very interesting, because it's always about the funding. It's the funding behind who fights who and who can bring to market, showing the right, materials. I think that's something to be very loud and proud about.
Yeah, and I'll give you a detail on that with Sudoc. First of all, Sudoc, the chemistry was invented by Terry completely. 40 years ago, he set out to mimic what are called peroxidase enzymes, which are in our livers and our cells. Peroxidase enzymes potentiate hydrogen peroxide, another natural chemical in our bodies. And he looked at it and said, God, it'd be fabulous if I could make a version of those enzymes that does the same thing, it potentiates hydrogen peroxide, but is small enough that we can produce it commercially. Peroxidase enzymes themselves are these big, awkward molecules that work in our bodies, but you couldn't manufacture them at scale. So he set out to do this, to biomimic peroxidase enzymes 40 years ago, and he's accomplished it. Not only are they much smaller and can they be produced industrially, but they are 1,000 times more powerful at potentiating hydrogen peroxide to oxidize bad stuff. Okay, that's the key part of this chemistry. And the key part of this chemistry is interesting enough that it will disrupt massively at least 15 major multi-billion-dollar industries if we do our jobs standing the company up correctly. So both Terry and I gave all of my stock in this company as one of the two founders of it. I gave all of my stock to what's called a irrevocable grantor trust, which means I can't benefit personally from the money, from the profits. But I can direct those profits to charitable giving to advance environmental health science and green chemistry. Terry's done something similar. So to collect our irrevocable trusts together, if we're successful, have the potential of becoming the biggest charitable funders of work in this field, period. That's exciting too.
It's fantastic. Yeah, it's exciting because, when we have all these things coming at us at all angles, you're talking about going through the biochemistry of the human body. Am I correct on that?
Yep.
And essentially, thwarting a lot of problems through biochemistry, essentially. But
yeah, we're not designing these to be applied to human bodies directly. We're talking about doing things like treating sewage water to remove pharmaceuticals and endocrine disruption, which is one of the biggest sources of exposure. Doing things like that, cleaning up stuff that's bad, that has gotten into the environment and is getting back into us. But I don't think it'll ever. There's some wild ideas afloat that suggest maybe in the long-term future there could be some medicines developed out of this technology, but we're not going there first. In fact, our first product, which has just gotten onto the market, is a way to oxidize black mold.
Interesting.
Very efficiently, cheaply, safely, faster than any current technology.
It's fascinating. I mean, something has to be done, right? Because we're seeing such an onslaught of exposure, body burden of these chemicals that are harmful, that are endocrine disruptors, that are immune system disruptors, that are metabolic disruptors. So, it can't come soon enough. Let's put it that way.
I agree.
Yeah. And I wanted to ask you some more questions because, honestly, it's really just a thrill to have you in this conversation. you've been doing other work besides just your chemistry and endocrine disruption. You've also have a long history of being an ornithologist, and you have a kind of an interesting background as one of the, your former senior vice president for science at the National Audubon Society. So tell me how this background in birds, in ornithology, in natural sciences really kind of, in other words, how did you come into this? Where did you get exposed that really, led you into this other path?
I got my PhD at Berkeley in ecological sciences, studying the ecology and migration of shorebirds. So ecology, systems, shorebirds. Okay, so I went to Reed College, where you got to learn how to think out of the box. That's my intellectual background. And as I mentioned to you, the specific path from ecological study of shorebirds to endocrine disruption was that meeting in Washington, D.C., where Theo Colborn came running up to me in the audience, which I described to you at the beginning. And the beginnings of that were that I was working in Peru and Chile for a number of years on the migratory and behavioral ecology of a species of bird called the sanderling. Now, if you live in New Jersey, you've been to the beach, you've seen those little white birds running up and down in front of the waves. Those are sanderling, okay? Now, they're in New Jersey, but in the winter, they breed in the Arctic, but in the winter, they spread all over the Americas, all the way down sometimes to Tierra del Fuego. Their mecca in the winter is coastal Chile and Peru. That's where most of them are. And I had been studying them there, and we could go into why would they bother to do that, and it's a fascinating story. But that's where they are in the winter, and that's where I was working. And people had discovered the Manomet Bird Observatory's data, had developed a system of tracking population size of different shorebirds, revealed that this population of sanderling might have fallen by 80 or 90% over a relatively short time period, a period of a decade or two. That's what I was studying, and I was thinking, what the hell is going on? Coastal Peru is a fascinating place. It's desert. It's unlike any desert almost in the U.S., and there's a lot of it, the whole coast. And I was driving on the beach all along this coastline, and I learned over time that I knew when I was coming to a town and a river mouth because I could smell the pesticides. These are rivers that are coming down from the Andes through the desert, flowing out into the ocean, and as they approach the ocean and they get out of the mountains, there's intense agriculture, and pesticides were dumped freely there, and I could smell it as I would be driving in that towards the city. And so I realized also that the sanderling, these birds, were preparing to migrate by eating invertebrates in the sand and the mud at the mouths of the rivers. So I developed this hypothesis that they were picking up pesticides heavily by eating contaminated invertebrates, worms, clams, stuff like that. And they would ingest the pesticides, and most of the pesticides are lipophilic. They are deposited in fat. And these birds migrate north based on the energy they accumulate prior to migration, which is the fat. So they get up and they fly nonstop 5 days, 6 days from one place to the next stopover site in migration. And in the process, they burn the fat. Well, the pesticides are liberated into the bloodstream, and where do they wind up? They wind up in the one remaining major deposit of fatty tissue, the brain. So I was wondering, so what happens when you get these this huge concentration of pesticide built up in the brain? And I speculated that it didn't kill them, but it could alter their ability to orient during migration, and then wind up flying off out over the ocean, never to be seen again, which is why we wouldn't see their bodies, because they were somewhere, in the middle of the ocean. So that's what I said in front of Theo in that audience, and that's why she came running up to me afterwards. Now, I was able to work with people from the Fish and Wildlife Service and show that there were large amounts of pesticides in the brains of shorebirds, sand-dwelling species of shorebird. Farther north in the migration system, we had samples from the Seattle area, for example. But I never, because I changed jobs, I never was able to pursue this hypothesis further. But I kept thinking it, and that was what drove me into this. And I am delighted to report that in about 2012, I was at what's called a Gordon conference on endocrine disruption, which is there are about 200, 300 Gordon conferences around the world sponsored by the Gordon Research Foundation and Science Magazine, where the elite of a given discipline come to share unpublished data. And I've been going to that for a long time. And all of a sudden, on the roster, on the program, is a woman from the University of Saskatchewan reporting on interference with migratory behavior in sanderling by pesticides.
Really?
So, I never published anything about my work there. So she happened upon it coincidentally, and she's been going strong ever since.
Wow.
Anyway,
it reminds me also of the work of Rachel Carson. So it seems to all of, where you're starting to see the canaries in the coal mines or the animals that are picking up these chemicals, and we're seeing and observing strange changes potentially, as your hypothesis was.
Yeah.
And then it's coming to fruition that there truly are effects from these exposures.
Yeah.
Which is what Rachel Carson, she died in 1952. 62.
She wrote in 62. She died in 64.
Oh, sorry about that. And but that she was just, it sounds like you are, carrying on the
Theo,
work.
Well, I'm honored by that observation. Theo is the one who really did this. Rachel Carson actually had some passages in Silent Spring, which clearly reflect endocrine disruption, but it wasn't called that then.
Right.
But you mentioned the canary in the coal mine. I have been using that phrase recently in lectures because I'm proposing that right now we are the canary in the coal mine globally, because lots of money, research money, has gone into research on the effects of endocrine disrupting compounds in people. Very little has gone into endocrine disrupting compounds in wildlife.
Mm-hmm.
By comparison, we know so much more about the mechanisms, the reality, et cetera, now in people than we do in wildlife. But we're seeing enough signs in wildlife to know that bad stuff is happening, more than we knew then. And so specifically with respect to Shauna Swan's work on sperm count decline, certainly tens, if not hundreds of millions of dollars have gone into the general study of fertility loss as a result of endocrine disruption in people and lab animals. About zero has gone into fertility loss in wildlife. And yet we share the same hormonal pathways. There's no way that wildlife is not being affected. And that some of the trends we're seeing in wildlife populations, I speculate, are being driven by the same trends that are contributing to sperm count decline in people. So we're the canary in that case.
Yeah, and to think that it wouldn't catch up with us, to think that we could, really create just so many, metric tons of chemicals and pesticides, and BPA is still, even though it was taken out of plastic baby bottles in 2012 in the United States, it's in everything else. It's in all of our other products, in our canned foods. And there are ways to reduce those exposures because of the half-life of BPA, for instance, being 6 to 8 hours. But essentially, we're sort of persistently exposed to a lot of these chemicals.
Mm-hmm.
And I asked the other day someone, we were talking about BPA and baby bottles and plastic baby bottles. And I thought to myself, if it was so bad and it was found to be logically a problem for newborns to drink from plastic baby bottles with BPA as an endocrine disruptor. How could it get into all of our other products, the canned foods and formula that feeds babies? I mean, at the very least. So there's so many ironies here that it's just it's kind of it's upsetting. But what I wanted to turn this around in sort of an optimistic way is, if possible, how do you see the future? I mean, you have kids, you have grandkids, grandkids. I think you have grandkids, right?
One grandchild,
granddaughter,
granddaughter.
Well, congratulations. I mean, the question is, how do you see the future? Are you optimistic? What are you thinking?
I think if we persevere and have some luck and have time, we can win this. But it's not going to be easy. I'm not going to give up. Fred's not going to give up. Terry's not going to give up because it's too important. But it's not going to be easy. And I see three things we've got to do. We have to redesign the chemicals in ways that avoid endocrine disruption. Essential chemicals that are widespread, we can change them. It's hard. It's hard because the industrial processes that use them have been customized to use them. And it won't be as simple as just taking one chemical and substituting it. You're going to have to change the processes. But we can redesign. We know enough science now to redesign. We have to reform. We have to reform the chemical regulatory system. It's bankrupt. It's corrupt. It's a false system that's designed to create a sense of safety when it's not there. So we have to redesign, reform, and we have to rethink. All the uses we make of bad chemicals right now are not necessary. Some of them are. But let's first get rid of the ones that are not necessary. Use substitutes for them, making sure those substitutes are safe. And then focus on designing chemicals that can replace the ones that are essential. The European Union has introduced this concept of essential use. There are essential uses. But that doesn't mean we have to forever accept that one chemical in that essential use now can't be replaced by something if green chemists work hard to refine the replacement. So that's my source of hope. I mean, so my granddaughter was born 2 months premature. And she spent the first 2 months of her life in the neonatal intensive care unit. And we both know that that's a great way to get endocrine disrupting compounds infused into you every day, 24 hours a day. And so I look at that and I think about that, and I know the plastics in that NICU saved my granddaughter's life. Mm-hmm. Okay? The way we've designed the system without understanding the risks, we have developed a system that saves lives. But what are the long-term consequences of those exposures? So now that we know that there are long-term consequences, what should we do to address them, to find different ways to accomplish the same goal? And actually, I was in New Jersey last week. And then actually, I was in New Jersey traveling to Bethlehem, Pennsylvania. Okay? Bethlehem, Pennsylvania is the home of a manufacturing plant of B. Braun, which is a German, privately held medical supply company, mm-hmm. one of the biggest in the world. And they had invited me. In fact, we are collaborating with them because they realized the conundrum their use of EDCs has created for healthcare, for health, for babies. And they're asking us to help them find ways to get them out. And they've committed $500 million to this. That's hope.
No, yeah, it's fascinating. When I used to lecture to grand rounds departments as a clinician about endocrine disruption, which I did for a few years, I would go to neonatologist grand rounds and pediatrician grand rounds, literally all over the East Coast. And I would say at the end of the lecture, after giving them all of this scientific basis for endocrine disruption and how it makes its way into even our children and our babies and Dr. Soto's work, or there's so many different studies. I think it was where they looked at all the tubing that goes into the NICU kids, and that kind of even the respiratory tubing. Actually, I think was one of the highest loads that goes into newborns. I said, does anyone want to contact me after this talk, and I will connect you with Healthcare Without Harm, and some of these organizations that really connect and can change out those plastics in a neonatal environment. And I never once had someone come up to me after the meeting to ask me how to change out their plastic tubing and IV tubing and all that stuff. Not once. And I did quite a few lectures. So it makes me feel that, it's not just on your end or sort of the end of creation. It's also on the communication and implementation that I worry about, given the medical system as it stands.
Yeah, I think that there's a generational change going on in medicine today. I see that. I spend more time than I like going to the hospital for my health care or my wife's health care, and I talk to physicians. There's a noted age difference. People who have raised their children since the age of endocrine disruption became acknowledged are much more attuned to this. It's wonderful to behold. Do you know Rob Sargis?
Yeah.
Rob is an endocrinologist at the University of Illinois, Chicago. He wrote an op-ed for Lancet. I forget which Lancet journal, which specific Lancet it was. Lancet Diabetes, I think. It's basically saying, we got a problem. We're supposed to do no harm first, and yet we are intubating people with endocrine disrupting compounds. And then I was reading just a month ago a publication of the University of Virginia, the hospital system there. And there was an editorial or commentary by a guy who's a urologist about endocrine disruption. And he was a young guy. Now, he's a friend now, because I befriend people who I see are receptive to it and are in a position to have an impact.
Yeah, you're creating a tribe.
Generational change. Yeah.
I think you're right, and I would say that I'm optimistic as well, even in the clinical world. But unfortunately, I'm not as tied academically into that world as perhaps I may be in the future. But the idea is that when young people are starting to see health issues as well, they're seeing parents and having endocrine disorders. They themselves are having thyroid conditions in their 20s. They themselves are having fertility issues. When it hits home, this is what I've seen with my own practice. With autoimmunity and the rise in those numbers, I think that we're going to find that people are going to really feel that it's coming so close to home that they have to make a change. And I think that's actually something will move us in the right direction, along with what you're saying as well.
It is moving us, unquestionably. Is it going to be fast enough? You look at Shauna's projections, mean sperm count could fall close to zero by 2045. That doesn't give us a lot of time. Now, projections are projections. It could be that we get our act together and eliminate enough EDCs from the environment that we can avert that curve and make it go up. But we've got to be working really hard to accomplish that goal. In a lot of ways, it's like climate change. We have to build the political awareness and the power to make the changes that are necessary, because there are vested interests that are deeply, deeply committed to the ways they make money today. And it's hurting humanity, it's hurting wildlife, it's hurting where we live on Earth.
Yes, point taken. Many points taken. Tell me 3 things you do in your own life that helps to cut down your exposure from endocrine disrupting chemicals.
Before I started this work, my favorite winter drink was Campbell's canned chicken broth. I haven't had that for 25 years.
Do you miss it?
I've been looking for substitutes. Yes, I've been looking for substitutes, and I found a few. There's some broth products I can combine that almost get me there, and they're organic. I eat organic. The conventional food, in theory, according to the regulatory agencies, rarely exceeds safe levels. their estimates of safety are fraudulent. They're outright fraudulent. And if you want to, and we know that eating organic food lowers pesticide exposure. That's been demonstrated many times. So I eat organic. I also have the good fortune of living in a 250-year-old log cabin without polyvinyl chloride, without with furniture that we know we purchase specifically not to contain flame retardants. Not everyone can do that, but I know my kids grew up in that clean environment, and I'm so thankful for it.
Yeah, it's great.
So
These are three things. Those are three things, simple things that you can do is buy organic. You can reduce canned exposure cans, which have BPA linings. Yeah.
I also assiduously avoid thermal paper.
And why is that?
Thermal paper, the stuff that comes out of ATM machines and cash registers and is on airplane tickets and is on baggage tags.
Parking tickets, all of them.
Yep. The surface of those tags or that paper is a coating of dust of bisphenol A. It's just on there as dust. And our mutual friend, Fred von Sahl, has shown that as you handle those, the dust is transferred to your skin and it's absorbed dermally through the skin at levels that easily reach problematic concentrations in your body. So I do everything I can. My organization accepts photographs of receipts, which I'll lay out. If I can't get anything else, I take photographs of the gas station pump to establish how much I bought to get a reimbursement. I use apps at my airlines that allow me never to have to touch a ticket. I'm working with the guy who invented the baggage tag system to show that they're contaminated by BPA and BPS. And there is a replacement now, which involves microchips embedded in bags that will eliminate the need to have baggage tags. Some airlines are moving faster than others, but that's really exciting. But here's one thing I guarantee I don't do. I was lecturing at a college to a class of seniors, fourth-year students, and I was talking about this receipt problem and described it, said, it's a problem. And one student put up his hand and said, Dr. Myers, I sometimes burn those papers. And I'm thinking, why would he burn the papers? And it's as if this other person read my thoughts. He put up his hand and says, he doesn't just burn them, he used them for his joints.
Not a good idea.
He's smoking joints made out of thermal paper receipts. It's a really bad idea. Yeah. And that night I called Fred, our mutual friend, and the next day he raised this issue he was teaching endocrinology 101 or 303 or whatever, and he raised this question to his students. Do any of you do this? And several boys put up their hands. Can you believe that? Here's why they do it. In addition to being the perfect size, you know how thermal paper works. Your audience probably doesn't. So there isn't ink in those printers. Okay, right. It's embedded with microcapsules of a clear dye. Yeah, and the BPA is on the surface. And as the paper is coming out of the printer, there are hot needles that are hitting the paper and puncturing the microcapsules and allowing the dye to release, and it rises to the surface and combines chemically with the BPA and changes the color to black. That's how the letters are formed. Well, it turns out when you burn those papers, the microcapsules sparkle. So you're smoking your joint and your joint is sparkling.
Oh, geez. Things that you learn. This That's really interesting because I teach high school and college students, so I never would have even imagined. But thank you.
Ask them. And I think that's a wonderful reason why risk assessment doesn't work.
Yeah.
Risk assessment assumes you know how people are going to use things.
Right.
It assumes that they will be used for the intended purpose. People find all sorts of weird, unexpected ways to use stuff that you put in the market and they got into their hands. And what you have to do is address the hazard, work to reduce the hazard.
And then give them rolling papers.
Possible. Yeah.
And give them rolling papers.
Yeah.
Give them an alternative for the good stuff, you know?
Yep.
No, I think you're absolutely right. You know, humans are always interesting creatures. I love sociology and all that because you never know what humans are going to do.
And what you're trying to do is make humans be smart. Thank you.
I'm working on it. I found a passion haphazardly, and I'm committed to really giving voice for this podcast to people in the endocrine disruption field and research, and lawyers. I had a lawyer on who was a environmental hazard lawyer, really good person, and just really interesting people that are on, I think, the right side of good, which I think is important to get out there. So as always, thank you so much for taking the time with this audience and really just giving just a wonderful, wonderful information. And it's really, truly been a pleasure. And I'm sure I'll see you at a meeting sometime soon.
Yep. Okay. Thank you for inviting me. And you're a wonderful interviewer.
Oh, thank you. And please keep up all the great work you're doing. It's just really wonderful.
I'm doing my best. Yeah.
Yeah.
Great.
Thanks, Pete.